STEM is kind of the way to go. Let me also bring this up to you though. You know, technical is one thing, but taking what you learn in technical is really problem solving. Really understanding why people make their decisions and really understanding how things are made is important, but you can apply that to anything. Just because I went into an engineering role after I got my degree doesn't mean you have to. So consider your options. It brings value to whatever you do, and you improve society no matter what you end up doing. So, you know, that being said, if you're interested in STEM, pursue it now. Don't wait till college. Go for it now.
Hey, you want to learn about electricity?
So I'm Eric Hurd. I am an engineer here at Eaton's Power Systems Experience Center. So here I get the opportunity to work on some really cool demonstrations like this, where we can take all kinds of products and be able to show people what they are, how they work, what they're for, and where they go. So it's a really cool opportunity to be able to do this. So I didn't actually start with Eaton as an engineer. I actually started as a technician. So here's where I started as a technician in the circuit breaker shop. This is where I found my passion for kind of working with that electricity in different parts of the power system. It actually drove me to go back to school at nights and weekends to go to college for many years, so that I was able to actually get that opportunity to get an engineering position with a great company like Eaton.
Hey, I'm Santino. I work here at the Power Systems Experience Center in Pittsburgh and kind of the man behind the camera. You're going to hear my voice a lot with the different narrations, and I was filming when Ariana was doing a lot of her different parts in a lot of these videos, so very excited to be here. I'm actually also a PhD student at the University of Pittsburgh. Here at the Power Systems Experience Center, I get a lot more hands-on interactions with power systems equipment like this crazy box of wires behind me. So very interested in STEM myself, and I think you should be too, because you get to work on a lot of really neat stuff.
My name is Ariana Nakai. I'm a graduate student at the University of Pittsburgh and I study electrical engineering. Today I'm going to talk to you about electrical loads. Have you ever heard of an electrical load? You probably haven't. And honestly, if it wasn't for studying electrical engineering, I wouldn't have known about an electrical loads either. So you may be wondering, what is an electrical load? An electrical load is anything that consumes electricity in the form of electrical current. There's three main categories of electrical loads: residential loads, commercial loads, and industrial loads. Let's go look at some. First, let's talk about residential loads, which are all the things that are powered in your house. Let's go look at some. Some examples of residential loads in your home might be your refrigerator, your stove, your microwave, or maybe even your oven, but even your lights.
Did you know that American inventor Lewis Latimer received a patent in 1882 for processing carbon filaments for incandescent light bulbs? He also founded the United States Lighting Company in Bridgeport, Connecticut, and wrote the first book on electric lighting in 1890.
Other residential loads, aside from the appliances in your kitchen that you might use every day, are things like your TV, your Xbox, or your sound system, and all the power comes in through service panels like this where your circuit breakers are. Or if you live in an apartment, it might look something like this. Now on to industrial loads, which may be found in a car manufacturing plant or a factory or even a power plant. Typical loads in an industrial facility might look something like this. 300 horsepower motors, and you might see equipment like this that help the motors run. So last but not least, commercial loads. This might be things like Heinz Field, or your favorite restaurant, or even an office building. Here at the PSEC Cafe, an example of a commercial load might be the lighting for the sign, or the coffee maker, or even the refrigerator that's used in a restaurant setting. Other examples might be computers for an office building, lighting used in office buildings, printers, fax machines, things of that sort.
I wanted to be part of something that, keeps things running. Like I just didn't want to just make everything just look fancy and, I don't know, do some suave code and things like that. I felt like I wanted to be a superhero in a way that I wanted to make sure that things are still running. I had that, on ground.
Have you ever seen watts when switching out a light bulb? Have you ever wondered what is a watt? Or perhaps, what is a watt hour? There's a difference between these two terms, and it's important to understand the difference. In a nutshell, watts measure power and watt hours measure energy over a period of time. A common analogy to try to understand these two terms a bit better is thinking of a marathon runner. It takes a certain amount of power to run a certain speed, but it takes a certain amount of energy to run a certain amount of distance. You can think of the distance as the watt hours and the power or the speed as watts. Let's assume you have a 50 watt and a 100 watt light bulb. In an hour, this will use 100 watt hours of energy. It'll take this twice as long to use the same amount of energy. However, since this is half the power, it's also half the brightness.
The first thing I'd say is whatever dream you have or whatever you want to become, do not relent, just keep pushing. And also seek advice from people who you admire in the field that you want to be in.
I would say just try to fuel your curiosity. It's really something that's looked down upon, and if it's not something in the mainstream, I just feel like there's not a lot of support system for that. So just try to find things or people that help fuel that curiosity that you have in science. Whether it's just literally chemistry, it's literally just the chemicals, the elements. Try to find out more about it. What it is about it, How are they being used, If it's the physics, if it's like electrons moving, try to find out more about it, and don't let anybody sort of deviate you from that path, and trying to learn about it. I just feel like it's something that in the realm of like 21st century generation, like everybody's really going into entertainment and a whole bunch of things, and I just feel like there's not a lot of emphasis in fueling that curiosity in engineering and even in just the STEM fields, to be honest. But yeah, I would just say find people and resources that help fuel that curiosity in you.
It's important to understand electrical loads because we use them every single day. The most common day-to-day electrical loads that we use are charging your cell phone, your computer, playing PlayStation or Xbox, watching TV, using air conditioning or heating, or even using wireless internet. You might agree, your cell phone is your most commonly used day-to-day technology. In fact, charging your cell phone is considered an electrical load because it consumes energy to charge its battery. On average, your phone consumes about 11,000 watt hours per year. To put that in perspective, the average US household consumes about 11 million watt hours per year. That's like charging your cell phone 1,000 times per day, but you likely only charge your phone about once or twice per day. Compare this to US-based data centers like Facebook's or Amazon's. They use about 205 trillion watt hours per year. This is about 19 million houses, or charging your cell phone 19 billion times a day.
I also have, little small hobbies on the side. I'm just trying to introduce my siblings, my younger siblings to it. Just trying to show them power electronics on a really small level as well. So we kind of tinker around with things like that at home. So yeah.
So you may be wondering, well, how does this information relate to me? Well, someday you're going to work for an automotive manufacturing plant, or somewhere in the medical field, or maybe in HR. Technical or not, you're guaranteed to be dealing with electrical loads in some way, shape, or form. Let's focus on medical hospitals, for example, and all the functions that are required to keep a hospital up and running. Hospitals are actually one of the most energy-intensive commercial buildings in the US, as they rely more heavily on electrical equipment for preservation of human lives. When we think of who the most important people are in a hospital setting, we may automatically think of doctors and nurses. And of course, they are extremely important to hospitals. However, doctors and nurses can't do their job without the support of other hospital staff. Let's think about some of the other jobs that rely on electrical loads that make a doctor's job possible, like designers for medical equipment, like ultrasounds or x-rays.
For example, in the past few decades, scientists have developed the laser, an electronic appliance so powerful that it can vaporize a bulldozer 2,000 yards away, yet so precise that doctors can use it to perform delicate operations to the human eyeball, provided they remember to change the power setting from bulldozer to eyeball.
CT scan machines, or electrical technicians or facility maintenance engineers responsible for installation and maintenance of medical equipment and keeping the hospital up and running. Or radiologic technicians responsible for operating x-ray machines and producing diagnostic images for doctors. Or even receptionists responsible for answering phone calls and scheduling appointments for patients via computer. But don't forget, there's a lot of other great jobs that don't require a college degree at companies like Eaton, like electricians, technicians, facility maintenance, and other related staff that also help keep the company running. Without understanding electrical loads, even at a basic level, none of these jobs would be possible. And how cool would it be to be part of the design of medical equipment that can help save people's lives? It's extremely rewarding to focus your occupation around something you genuinely enjoy doing every single day, making the paychecks that come along with it just a big bonus. If you're wondering what job or field you best fit into, when thinking about the types of jobs that make a great contribution to society, think about the things that you're interested in and how you can make a lifelong career out of it so you can also make a great contribution to society as well. Every time I talk to a friend or a coworker about how they got to where they are at with their career today, everybody has a different and unique story. I, for one, have always been interested in math and science, and for that reason, I decided to study engineering. But a lot of the other people I work with aren't engineers. There's a lot of other jobs like marketing, communications, or HR that help keep any company that you'll work for up and running. Discussion questions. What are 3 more examples of residential loads that you can think of? What is another analogy for watt and watt hours that you can think of? Well, what about a receptionist job? What are the types of electrical loads that make a receptionist job possible, which in turn make a doctor's job possible? So now, how about a math question? Let's assume you have 10 100-watt light bulbs in your house. Your parents keep asking you to turn off your lights because you left them on overnight. Assuming the electricity rate costs 10 cents per kilowatt hour, how much could you save in 30 days by turning off the lights for 12 hours a night? With 10 light bulbs, each being 100 watts, that would be a total of 1,000 watts, or 1 kilowatt. For every hour the lights are turned off, you would save 1 kilowatt hour of energy. So, over the course of 12 hours, you would save 12 kilowatt hours of energy. At a typical rate of 10 cents per kilowatt hour, you would save $1.20 per day, and over the course of 1 month, you would save $36. With these savings, you could buy 3 large pieces every single month.